and welcome to another episode of Science Unboxed with Professor Matthew, where we explore advanced, somewhat complex scientific concepts, and we reduce them into biteable pieces that can be digested by the human brain quite easily. Now, we are first going to explain what this device is, this right here. So this is a mini cyclotron. Now, what does a cyclotron do? Well, a real cyclotron speeds up electrons. Now, I don't have electrons, I have these little balls, okay? And this device is going to speed up these magnetic balls, and basically I have a coil through each of these parts that produces an amount of electricity, which causes it to move. It causes a moving magnetic field, which shoots the ball through the device as so. So a moving electric field causes a moving magnetic field. Moving magnetic field causes a moving electric field, hence electromagnetism. So we're going to explain how this has to do with quantum mechanics, all this and more in a second. Stay tuned. I have this cyclotron here. I have this little mini cyclotron. And if I have a ball in it, and it's going to accelerate really fast. That's a little bit loud. So I had a little ball, and it was going around very, very fast at a velocity, at an angular velocity. So it had momentum, was exactly what that ball had. It's the mass of the ball times the velocity it was going, how fast it was going. So that's what momentum is. I wanted to show you exactly what momentum is because it's a very important part to today's talk. So where are we going to start? Well, we're going to start with German physicist Werner Heisenberg. He noticed a problem that physicists encounter when they attempt to measure the speed and position of quantum objects. He codified these observations into a principle that has come to be known as the Heisenberg Uncertainty Principle. The more we know about where a particle is, the less we know about how fast it's moving. And the more we know about how fast the particle is moving, the less we know about where the particle is. Because how fast something is moving is related to its momentum, which is the mass of the particle times its velocity. This uncertainty principle is often stated as an uncertainty between position and momentum. I know we don't usually go over equations, but we'll have an equation where the change in position times the change in momentum. Remember, momentum, we can really think about as speed, has to be greater than or equal to Planck's constant, which is a very, very small number. We talked about that a couple lectures ago. That was that fudge factor, the graininess of the universe, over 2 pi. All right? So that's the first part we need to know. Now, we have to first review a couple things about waves. Now, let's go over the types of waves. There are a few different types of waves. In each case, we want to think about how much knowledge we can actually get from the wave pattern, exactly where the particle is or how fast it's going. One type of wave is flat in most places. On one side, it's flat, and then there's a wiggly part in the middle, and then it's flat again. And where the wave is flat, you're not going to likely find the particle, like the electron or the photon. But where the part is wiggly, that's where you're likely to find the electron, photon, or whatever subatomic particle you're talking about. Follow me at Professor Matt W on Spotify, Apple, Amazon, and also anywhere you can, any type of social media, TikTok, Instagram. Stay curious and stay interested. Thanks.